Welcome to this video on Electronic Flight Instrument Systems, or EFIS. We will cover the architecture, operation, and maintenance of these critical systems. EFIS systems originated in the late 1970s and early 1980s, introducing the glass cockpit concept. The purpose was to reduce clutter, improve reliability by having fewer moving parts, and reduce maintenance costs. The system architecture is designed for redundancy, usually split into left, right, and center systems. Each system is driven by its own symbol generator and receives data inputs from multiple sources like IRS and air data computers. The main display units are the Electronic Attitude Director Indicator, or EADI, and the Electronic Horizontal Situation Indicator, or EHSI. These display essential data, including attitude, airspeed, heading, and navigation information like VOR DME. Power supply units typically use 115 VAC, 400 Hz primary power. While modern LCDs require less power, older CRT units needed a high voltage supply, up to 20 kilovolts, to accelerate electrons. EFIS displays use 6 assigned colors to convey information quickly. For example, green shows active data, magenta indicates, quote, fly to commands, and red signifies warnings. Symbol generators, or SGs, process sensor data into video signals. They use raster scanning for backgrounds and stroke scanning for sharp symbols and text. A third symbol generator acts as a hot spare backup. If an SG fails, the pilot can use the source select switch to route both displays to the center SG. Control panels allow pilots to interact with the displays. Functions include selecting range, changing the EHSI format, setting the decision height, and adjusting brightness. Remote light sensors automatically adjust display brightness based on ambient conditions. These sensors are located on the glare shield or built into the display bezels, with manual override available to the pilots. The EHSI has principal navigation display modes, including MAP for standard cruise, Plan for route verification, and VOR ILS for traditional navigation views. The expanded map mode is the standard cruise setting, oriented, quote, track up. It shows the route ahead, waypoints in magenta, and allows weather radar data overlay. The plan mode is true north up and features a static map for flight plan review. In this mode, the aircraft symbol is centered and weather radar is not displayed. The VOR ILS mode displays a traditional 360-degree compass card. It is used for VOR navigation or ILS approaches when map data is unnecessary. Weather radar video is fed to the symbol generator and overlaid on map or VOR/ILS expanded displays. The color code ranges from green for light precipitation to magenta for turbulence. Data failures, such as ILS or heading, are indicated by yellow flags replacing the data. An SG failure can cause a blank or distorted screen, requiring the pilot to switch to the standby SG. Advantages of EFIS include reduced mechanical wear and improved data presentation, reducing pilot fatigue. Disadvantages include electromagnetic interference from high-frequency switching and significant heat generation requiring cooling. These are the image sources used for the content in this video. More image sources used for the content in this video